I'm going to talk to you today about section 1.1 from the XYZ textbook on the real number system. So first, we're going to talk about the properties. The first one is associative property. Numbers can be grouped in any order when adding or multiplying. In other words, you can say 1 plus 2 plus 3 with the parentheses around the 2 plus 3, and that is going to be the same thing as 1 plus 2 plus 3. So that is true for addition, and it's also true for multiplication. So I could say 1 times 2 times 3, or I could say 1 times 2 times 3, and those are both equal to each other. The commutative property says that numbers can be added or multiplied in any order. In other words, 5 plus 3 equals 3 plus 5, and the same thing for multiplication. If I had 5 times 3, that would be the same thing as 3 times 5. Commutative property. Distributive property states that you can distribute numbers. So if I had 2 times 5 plus 3, that would be the same thing as 2 times 5 plus 2 times 3. And of course, then you can go the other direction as well. We call that factoring. The additive identity basically is the number 0. So if you take any number and you add, I like 5s today, and you add 0, you get that same number out. Looking at the multiplicative identity, that number is 1. So if you think about it, if you multiply anything times 1, so if I have 7, I take it times 1, I get 7. So the multiplicative identity is the number 1. So the next is the additive inverse, which follows from the additive identity. What can you add to a number to get 0? And that is always going to be the opposite, or the negative of the number. So the negative of, say, 6, what would we add to that to get 0? Well, we would add negative 6, and that would give us 0. So additive inverse is what you can add to something to get 0. Multiplicative inverse is what you can multiply by to get 1. Not 0, it's 1. So it's the identity that you're trying to get to. So what could we multiply 8 by to get 1? Well, we would multiply that by its inverse, its reciprocal, and that would be 1 over 8, and that would give us 1. So those are two very important things to understand right here, are the inverses, both additive and multiplicative. Okay, so next we're going to look at some examples of these different properties so that you can learn to figure out which one it is. So looking at A, we've got 4 plus 6 equals 6 plus 4. This is an example of the commutative property. Commutative, not commutative, so it's commutative property. B, 3 times the quantity 5 minus 8 equals 3 times 5 minus 3 times 8. That is distributive, so the distributive property. The next one, if you can look at this, it's got 2 times 3 times 5 on both sides of the equal sign, but the only thing that's changed is the parentheses have moved. So that is the associative property. And I'm going to shorten that by just abbreviating associative property of multiplication. So of multiplication. There's also one for addition. And the last one is just showing us the multiplicative identity. The multiplicative identity. All right, so next I'd like you to look at check it out 1 down here at the bottom and tell me what property does that illustrate. Okay, next we're going to look at how to go from a graph to writing it as an equality or an inequality and as interval notation. So inequalities are something you've probably worked with for years, and it's dealing with things like less than or greater, less than or equal to, greater than, and greater than or equal to. Interval notation uses parentheses, and a parenthesis that looks square means that we are including that number, and one that is curved means we're not including the number. So I'll talk more about that. So this first one is from A to B, everything from A to B, including A and B. So these two dots here represent the fact that we are including A and B. When it's an open circle, like it is right here, that means we are not including A or B in those cases. All right, so the first one we're going to write as A is less than or equal to X is less than or equal to B. In interval notation, we don't include the X, which makes it actually a little bit simpler. And we would write this as a square bracket because we are including the A, and a comma, which means everything between, all the way up to B and including B. So that's all you have to write. And you have to understand that you're writing interval notation and you're not referring to a point or something on the coordinate graph. So you have to know what situation you're dealing with. So the next one is A is less than X is less than B, which we would use curved parentheses for, saying everything from A to B, but not A and B. All right, the next one is going to be A is less than or equal to X is less than B, because B is not included. And this one we would write with a square bracket on the left and a curved bracket on the right, because we're including A, we are not including B. We do the opposite on the next one. So A is less than X, but not including A, is less than or equal to B. But when we write it as interval notation, we say curved bracket A, because it means not including A, and up to B, but not but definitely including B. Sorry, I misspoke. All right, the next one goes from A to infinity, and the way we write that is X is greater than or equal to A. And the way we write that in interval notation is it goes from A, and including A, so we use a square bracket, up to infinity. And I write infinity as two circles, so it's a little tidier. And we use a curved bracket on infinity. That is always the case because infinity is not a number that we can actually ever reach. So it doesn't include the number infinity. There's no stopping point. That's for another discussion. All right, so the next one is X is greater than A, not including A, so we don't say or equal to. And in this case, we use a curved bracket A up to infinity. And both of them are curved because neither one of them are included. The next one is X is less than or equal to A. And we are going to write that, and it goes down to infinity. So we're going to write that as a curved bracket, negative infinity. So that means in the negative direction all the way to infinity, up to A, with a curved bracket on the A. I'm sorry, a square bracket on the A because it includes the A. All right, the next one is X is less than A, but does not include A because it's an open circle. And in this case, we say from negative infinity with a curved bracket up to A, again with a curved bracket because we're not including A. All right, the next one goes from negative infinity to positive infinity. So we would just write all real numbers. That's how we would explain that. And if we write it in interval notation, we would say from negative infinity to positive infinity with curved brackets on both sides. Okay, here we have an example of what I just showed you. You're going to graph each of these, so I want to talk you through it. A is from -2 to 3, and -2 is not included. So we start at -2 and we put an open circle on the -2. And then we go up to 3 and we include 3. So it's a closed circle or a dot, and then you're going to put a line in between. All right, the next one goes from negative infinity, which is over here, up to 4, and 4 is included. So 4 is going to have a solid circle, and you're going to draw a line all the way and then put an arrow over here so that you show it going all the way to infinity. All right, next I'd like you to try giving a verbal description of this next interval and graphing it on a number line on your paper. Okay, so I wanted to show you the answer to this one. So this one goes from 3, including 3, up to 5, including 5, and you put a line in between showing everything in between. Okay, this next one, we're being asked to write the interval that's being graphed here. So it starts at -3 and it goes up to 2. And we have to decide what shape brackets we're going to have. So the -3 is included, so we're going to use square brackets. The 2 is not, so we'll use a curved bracket. You try answering, check it out 3 over on the side with the intervals shown in the graph. Next, we're going to talk about the definition of absolute value. Absolute value is a piecewise definition, piecewise function. And so the absolute value is denoted with the 2 straight bars on either side of the x. And if it is positive, if x is greater than or equal to 0, then it just equals what's between the brackets. And if it's less than 0, you take the negative of it. An easier way to think about it is just make it positive. Do what's inside the brackets, the straight lines, and make it positive. So the first one is just going to be the absolute value of -3 is 3. The next one is -4 minus, and you want to just do this and then work it out. So the absolute value of 4.5 is 4.5, so you want to get rid of those brackets. -4 minus 4.5 is -8.5. All right, next we've got -4 plus 9 in the absolute value, so you want to work that out first. So -4 plus 9 is 5, and we take the absolute value of that plus 3, and absolute value of 5 is 5, plus 3 is just 8. You try the check it out, number 4, down below. Right now we're going to apply absolute value to the distance between 2 points, which is always positive. You can subtract the 2 points from each other and you will always get a positive, because distance we refer to as a positive number. So find the distance between -6 and 4 on the real number line. -6 is over here, -6, and 4 is here. So we want to find the distance between these two numbers. So we can look at this as either 4 minus -6 absolute value, which is going to be 4 minus -6 is 10, so absolute value of 10 is just 10. The other way to look at it is take it the other direction. You can do a minus b or you can do b minus a, so I'm going to show you both. -6 minus 4, and that is the absolute value of -10, which is 10. And in either case, we get the distance of 10. You try check it out, number 5. Next, we're going to talk about order of operations. You've seen this before. The acronym is PEMDAS, and it stands for parentheses, which we do from the inside out, exponents, then multiplication and division, then addition and subtraction in that order. So you can pause here and take a screenshot of this or put it in your notes if you would like. Now let's try some examples. The first one, 3 squared, is 9. So the first thing we want to do is write that down, the 9. You can do the exponents and the parentheses because they're in separate parts of the equation. Or you can hold on to the 3 squared and do it later. Plus 2 times -3 plus 7 is 4. So we've got 9 plus 8, and that equals 17. All right, next we've got a rational expression, basically. So we've got 3 squared plus 1 on top, and we need to do that separately from the bottom, and then we'll put them together. So 3 squared is 9. Plus 1 on top, and 4 minus 7 on the bottom we can go ahead and do and say that that's -3. So we get 10 over -3, which we can also write as -10/3. You can bring the negative out front if you'd like. All right, the next one we've got a double set of parentheses here, so we want to do this inside one first. So we're going to say 6 plus 3 times 5 minus -3 squared is -9. The negative is not squared. Plus 2. So we've got 6 plus 3 times 5 minus -9 plus 2 is -7. So then we come back out here again and we do what's on the inside. 5 minus a -7 is 5 plus 7. So 5 plus 7 is 12. And next we get 6 plus 3 times 12 is 36. So this is 42. You try check it out, number 6.